case key, we'll set k to be the current key, and we'll make sure that part index starts at -1. This is the index of the part for keys. And case looping. If looping was written to file, then we know that it's supposed to be looping by default. And if it's a time, based on the current key, we'll set the time for the current key to what we read. And then if it's a part, then we can say part index ++, and because it started off as -1, then the first part's going to be 0. I just realized a correction I need to make here. I told you before when I was discussing keys that if part is non-negative, then it's for swapping parts, which may have been true originally, but now part actually represents which part is to be rendered. So if part is swapped, so which actual sprite part is to be rendered. So say anim a.keys part index key index, and we'll make a new one. Part is equal to, and we have to add in the first index, the offset by first index, and we'll say active is true. Break case order. So that's the order that it's drawn in. If adjust order, keys part index key index dot order plus equals first index. And this is for if you're going to have your custom player operate a different way. I would say don't even worry about this line. You might not even want to put it in there. You don't actually need this adjust order or this line. So if you want to take them out, you can. It won't matter. So case not active. Active is false. Case key scale. Convert to single. This is a floating point. This should be anim. Okay, so that gets the scaling for the x, and then for the y, it'll be the second string. Break, case rotation, key rotation, just copy this. Break, key for position. This is copy this whole line here, change this. Dot pose, dot x, let's times it by rescale. Oops, times rescale, dot x. And do the same thing for the y. Position.y, rescale.y. Make sure that this is set to 2, and then break. Case key alpha dot alpha. Alpha is also floating point. Actually, let's copy this line here. And this will be key vert off 1. This will be O1 x. X factor is scaled. Change this one to O1.y, and y is scaled. Copy the entire line. Paste it a few times and change this to 2, 3, and 4. Same here, 2, 3, 4, and then move over to here, 2, 3, 4. Okay, so if total animations after is greater than a, let's say total animations equals a, just to be safe. Then we'll do a loop here as a precautionary setting of the second key in case there's no other keys. Always better safe than sorry. Else, so if the number of keys is greater than 1, then the second one we set to 1. And here we're going to say while a is less than total animations, a++, and here we'll say anim a.key2 equals 0. And we don't really need that in brackets. We can just say else, because it's only doing one thing. In fact, we could really do that here too, in the brackets. So what this precautionary loop does is, for any of the animations, it initializes the starting keys for the animations. Key 1 is the current key, key 2 is the key it's interpolating towards, and it just keeps updating key 1 and key 2 as it runs the animation. Usually you want them to start off so that key 1 is 0, key 2 is 1. So if there's only one key in the entire animation, then it will say key 1 is 0, key 2 is 0. But otherwise, if there's more than one key, it'll just make sure that the second key is 1. The first key will be 0 already. So just to be safe, I'm just putting this on one line just to take up less space. This actually is kind of unreadable, so if you don't want to do that, don't do it. Let's allocate memory for the final rendering, a final render for all the parts. Do another loop where we'll set those up. Just make sure we allocate the memory for all our parts, and that should be the end of load txt for MeoMotion. Do a save. Down below our txt, we'll add a method that allows us to get the index of an animation using the sheet name or character name and the animation name. It'll be called getIndex, which will take a string sheet name, string for animation name, and a Boolean option for showing error messages, true by default. So return an integer value. If not lookup.tryGetValue for sheet name plus animation name. Our output parameter is value, and that's if it's successful. So if it didn't work and show error messages, it's true. and we'll write an error message. Animation not found in dictionary. And what it is, what we were trying to look up, return 0. And for rescaling based on resolution, we're going to create a method called adjustScale for resolution. Paused it for a second. So we'll need a reference to a vector 2. That way any changes we make to the vector will be reflected in the caller. An integer for width, an integer for height. And those are the resolution settings we want for our target. Assuming a default of 800 by 600, and that sort of aspect ratio, our rescale x is going to be rescale.x times width divided by default. And typically I would use 800 by 600 resolution as my target resolution, and that would be stretched to whatever resolution the desktop display is at. And that's just because I get really good performance with that, and visually it looks pretty good like that. If you like a higher resolution version, you could change it. This will still work. You just have to set slightly different rescale factor. But you could also change this in here too. So either way is okay. So let's save that, and that's MeoMotion, or MeoMotion if you want to pronounce it that way. So go over to your MeoMotion folder in Solution Explorer, right click on it, and add a new class as a C# file called MeoPlayer. Go back into MeoMotion for a second and change the namespace to just platformer, then go into MeoPlayer, and for simplicity we're going to just use a namespace of platformer for the entire project. So the first thing we'll add to the MeoPlayer is a Boolean for pre-multiplying alpha. We'll set that to true as default. So depending on whether you're using non-pre-multiplied or pre-multiplied, you may want to change that. Otherwise, you get some sort of artifacts along the edges of your transparent pixels in the pieces of your character, and you don't want that. So I'll create a constant float called height alpha under, and that's sort of the threshold for the minimum alpha, so that anything lower than that's clipped from the calculations. And we'll have a vector 2 position, that'll be the character position. We'll have a string for the sheet name. Oh, we got to resolve our vector. An integer for animation index, which should be animation underscore index. So that's the current sheet name, current animation index, the current play speed that the animation player is using, and some booleans for determining what to do. So if it's stopped, if it needs to flip the animation horizontally, if the animation is active, if it has to play it in reverse, if the last time it did a loop, it was playing it in reverse, so it knows how to switch it back to forward if that's what it's doing. Also, we need to know what the current key is and what the next key is going to be. And privately, we'll keep track of the timing using a timer. We'll also have a Boolean that determines, or that can communicate whether the animation is done or not. A part count for our final rendering, and our final rendering data itself. We also want to reference our quad batch, which will be used for drawing the distortable MeoMotion animations. And we'll also want to reference to the MeoMotion object that we're using so we can access its members. So I'll pause it real quick and I'll just add some comments here so that you can understand what these members are for a little more clearly. Okay, if you want, you can pause the video and copy these, or copy something similar, maybe shorter. We'll move on to the constructor. Okay, I'm just going to pause it. Okay, I'm back. Just wanted to add a more detailed comment for the constructor of the MeoPlayer. It'll take a string for the sheet name, which represents which character it is that we want to use. A starting position for the character. Under a lot of circumstances, that won't really matter. We want to be able to access our MeoMotion instance and also access our quad batch. So first of all, let's have it remember the sheet name so it knows which character to use, which section of graphics on the sprite sheet. We'll set the position, the starting position. We'll set the initial play speed to be 1 equals 1.0. We'll reset the part count to 0, although since this is a constructor, it should be 0 anyway. Flip should be false anyway. Same with reverse. And we'll get access to our Meo class. We'll allocate memory for the final render data. So we'll need to make sure we at least have enough for the maximum number of parts available, plus 1. And we'll loop through to set up that memory. And we'll loop while a is less than max parts plus 1. Allocate. Alright, that looks good. And make sure we get access to the quad batch. So the first thing we want our player to be able to do is set the animation using a string for the animation name a Boolean to determine whether it starts off flipped or not. That's flipped horizontally. You can add more options if you want. And if play backward is how it should start. By default, that's false. Alright, so I just unpaused it again. If animation name is none, so if you just don't want this animation player to play anything right now, you can specify none if you want. It will set the animation to false and return. Animation index, so we can get the index using the sheet name and the animation name. That way, when we want to set an animation with a character that's associated with the MeoPlayer, because the character is already associated using sheet name, all we have to do is specify the animation, if it's walk or run or whatever. We'll make sure to find out what the part count is for it. So part count is the Meo animation's end part minus its start part. We'll set flip to be the default flip passed in. We'll say active starts off as true. Key 1 will always be 0, key 2 will always be 1 when you start off. You can override that. Of course, you can override active also. Timer starts off at 0, which it should always do. The animation is not done yet, because when we set the animation, by default, it's playing the animation. Stopped is false, reverse is false, and last reverse is false. So if playing backwards, then we'll start it in reverse. We'll have to create a method for that. Let's say we already know the index, and we don't need to supply a animation name. Let's make an overload for that scenario. So instead of string, we'll have int animation index. For some scenarios, I like to have this option. If we already know the index. If not active, active is false. Return. Animation index is the supplied animation index. Missing a curly bracket here. Okay, I added a few comments. Let's move on. So we need something for this start reverse. Prepare for playing the animation backwards. So start reverse. We'll set key 2, which is the second key it interpolates towards. Number of keys minus 1 because we're just starting the animation. So it'll be the last key and key 1, key 2 minus 1. So actually, key 2 is still to the right of key 1. Key 1's to the left. But it'll play the animation reverse going from key 2 to key 1. Done animation is false by default. We'll make sure to settle our booleans. And we are playing it in reverse. We'll need to know that when it does the interpolations. And we need to set the correct timer value. So initially it's going to be key 2 timer value. So that's the time it is on the timeline. And it'll play backwards from the second time, the key 2 time, to the key 1 time. Something to keep in mind, if it's in the middle of an animation and we're playing the animation forward and we just switch to reverse or vice versa, then we want to make sure that when it checks to see if the animation is done, it doesn't think it's done just because it's on the last keyframe. So let's make a helper method here to check if the animation is done. And this will be a little bit smarter than just using a Boolean, because things can get a little complicated when you add the ability to play the animation in reverse. So like if you're ducking down, for example, and you want the animation to start in reverse, so that the character starts standing back up, and it switches from one state to the next, forward playing to reverse or vice versa, then we want to say that the animation is not done. So return false. Just played. Now in the regular scenario, if done anim is set, we can reset it to false because we're returning true to say that we've finished playing this cycle. That way it only resets the status when an is done animation is actually checked, and that can come in handy. And then for the actual animation updates, I had some comments here. So public void update. We'll take the game time in case we want to control it based on that. Like if it's going to have some slowdown or if it's online, then we'd want to use this. Under some circumstances, if it's single player, multiplayer at home or something, you might not care if it has slowdown, but chances are extremely good that it will always maintain 60 frames per second, so you probably don't have to worry about that. If the animation player is not active, then we just return, and we'll set A to be the animation index, so we don't have to keep typing this animation index over and over. We'll use small variables here so it's more readable. We know what this stuff means anyway. Key 1, key 2. The whole idea is we want to use variable names that are easy to understand, but sometimes when you know what they all mean and it's very obvious, better to use smaller names because then you're not looking at a massive amount of code and it's easier for your mind to digest when you look at it. So we're going to need to calculate the time difference between the keyframes and the percentage between those two keyframes, 0 to 100% or 0 to 1, and that's used for the interpolation process, so you can blend your animation frames together. If we're in looping mode, then by default we're going to say done animation is not true. We're going to say it's false. And we have other ways of checking to see if it's actually hit the end of a cycle if we need that information for whatever reason. So we're going to have if reverse and then else. So two different treatments of how to handle animation. I want to keep each treatment completely distinct so as to avoid any mistakes that might not be obvious. So I'll explain this in a second here. Play speed needs to be adjusted based on the default animation speed for this animation. So we have the local playing speed and then our desired default speed. The desired default speed is a percentage, 0 to 1. If you wanted it to be double, it would be 2. Triple, it would be 3. Half, it would be 0.5. I think you get the idea. So that speeds up or slows down how fast this timer has advanced. So later on when you're setting up animations and initializing or doing custom initializations, you can set each animation speed. So if it's a walk animation or whatever, and you know how fast it was in the original editor and how fast you'd like it to be in the game, you can kind of adjust it that way. Your timing's done in milliseconds, and when you're using game time, that's clearly what you'd be wanting to use. So for example, you could use the game time milliseconds and then do exactly the same thing to adjust the speed. Since we want to lock this at 60 frames per second, which with monogame it does by default, during the page flipping in game 1, for example, right here in base game draw, when it does that page flipping, it's going to do it every 60 frames per second. So it's going to adjust the timing, and that's the default behavior. And yes, that can be changed, but we don't want to change that. So I'd actually rather not use the game time for this. I have reasons, so let's do this instead. We'll provide the option here. If you're doing an online game of some kind, you may want to use this method instead. So this is actually 1000 divided by 60 because we want it 60 frames per second. So 1000 milliseconds divided by 60 is 16.6 repeated.